So why did you come back? I know how you feel. Never mind. I would be
I put that back in.
What?
Mr. McGee. Mr. McGee, can I go get my pal back out?
Okay, here we go, guys. So we studied what in 6-1? What was the main topic that we looked at in 6-1? Polygons, right? Now what's a polygon? Some examples, anything? Square, triangle, hexagons. Okay. So we learned about angles and so forth in all the different polygons, how to find the sum of the interior angles, how to find the sum of the exterior angles, how to do things like that. So what we're going to do for the rest of chapter 6, real fast, is we are going to study all the different types of quadrilaterals, squares, rectangles, or some other quadrilaterals. Four sides. What else? There's lots. Parallelogram, rhombus, trapezoid, and kites. Okay, so we're going to look at those in more detail. We're going to do quick. So, the most general type of quadrilateral, like the next level down, is a parallelogram. So we're going to start with that. So we have a definition. What is a parallelogram? It's a quadrilateral. All that quadrilateral means is what? What's that mean? What's the root word quad?
Four.
Four, right? It's four sides. Anything with four sides that's a polygon is a quadrilateral. But a quadrilateral with two pairs of parallel sides, that's what we call a parallelogram. So it must have two pairs of parallel sides. One is not sufficient, it has to have two. Now what's the symbol we usually use to show sides that are parallel?
The arrows.
The arrows, good. So like that side's parallel to that. And should I do this?
Yes, we can say you have to have two pairs.
So these are all four parallel?
Oh, you should make two.
That makes more sense, right? So not all four. So that's the main definition of a parallelogram. Now, once you have a parallelogram, what do you know about it? So that's what we're going to learn in a few theorems, okay? So, I don't even think I'm going to write out these theorems. So if it's a parallelogram, you know some different things. Let's just look at it as pictures. Okay? There's four different things that I'm claiming. I'm telling you, yes, they are parallelograms. You really wouldn't know that for sure unless I told you. Why would you not know for sure?
Because you don't know if the sides are no marks.
The marks aren't there, right? If the marks aren't there, you can't be sure that they're parallelograms. And some of the problems are going to ask you, is this a parallelogram or not? You're going to have to say. So here's some other things that you know if it's a parallelogram. If it's a parallelogram, then the opposite angles have to be the same. So those two are the same. And these two are the same. Okay? That's one thing you know. If it's a parallelogram, then you know for sure those opposite angles are
Mark
the same.
Sheehan, Samantha Wagner, and Claude Baudino to Student Services.
Okay. If it's a parallelogram, you also know now how you draw this is kind of different. It depends. It's kind of hard to draw. But if it's a parallelogram, you know that consecutive angles, the ones that are, what's consecutive mean?
In a row.
In a row, yeah. The ones that are next to each other, you know that they've got to add up to 180.
So if you've got.
So I know that like this one, let's number them.
Like if those two on the left and right are the same, then that means the one at the bottom right and the top left.
Yeah, it's kind of like that's where it comes from.
What's it
Logan,
showing
yes.
in number 1?
So here's what I'm telling you. I'm telling you the measure of angle 1 plus measure of angle 2 has to equal
Measure of angle 3 plus.
180. And measure of angle 1 plus 3, you guys watching?
Saying 3 equals half.
Plus 3 is also equal to 180. And you guys are saying you could like exchange some of them, and that's true as well. Okay? So the way that you'd say this one's pretty obvious. This one's, you might need a statement. So here's how the theorem would go. It would say if a quadrilateral is here's the symbol we use for parallelogram. You could write it out or use the symbol. That's the symbol. Then what kind of angles do we call these? The ones that are next to each other? Consecutive. Very nice. The consecutive angles are, what do we call it when they add up to 180? They are linear periop. What's another way to say it? They're not, are they really on all, they're not on line.
Yeah, okay, there's something like, I get the two things up.
So these two add up to 180, these two add up to 180, these two add up to 180, these two add up to 180. So they're next to each other, then they add up to 180.
And what's 1 showing you? The chart number 1. Yeah.
1 says that if it's a parallelogram, then opposite angles are
The same.
the same. Congruent, right? I didn't think we really need to write that.
Okay.
Number 3 says if it's a parallelogram, no matter what, if it's a parallelogram and you get the diagonals, what do you think might be true about those diagonals? They look kind of the same, right? Like same length or something like that. What they do is they cross, what's the center of a parallelogram?
Oh, it's not central. It's
Yeah, you don't know, right? Did you know that? What do we call that when it's cut in half? That one's cut in half where they cross, and that one's cut in half where they cross. Doesn't mean they're all the same. It's called bisection, right? So, if a quadrilateral, you guys, talking during lecture is not cool, so stop, please. So if it's a parallelogram, you know those diagonals are each cut in half. Doesn't mean they're all the same, that's why I didn't put 1, 1, 1, 1, right? Now maybe specific other types of quadrilaterals will work like that, but not parallelograms. Okay, that's pretty much it. That's all we know about parallelograms. Opposite angles are the same. The consecutive angles add up to 180. And the diagonals bisect each other. And that's the stuff you're going to be using in this section. So I'm not going to do examples. I think that these couple sections we're doing for these 2 days pretty easy. Might be a couple tougher problems. Let me do one proof. As we move on in the second semester, proofs are going to be phased out. It's like a couple in this chapter. I'm not assigning very many. There's like 1 or 2 in the next chapter, and those are fairly easy, and then done. Okay. So
that shit.
Okay. So, what did they tell me? What was I provided with?
A, B, C, D is a parallelogram.
This thing is a parallelogram. So you know all those three theorems we learned, we could use any of those three theorems. Any of that information is fair game. Okay. Our goal is to show that this triangle is
Are congruent.
congruent to this triangle, same exact triangle. So we're trying to show that this one is the exact same triangle as this one. All we know is that the parallelogram is a parallelogram. Okay? So we're trying to use properties to show that those triangles are the same.
First, you could use the sides. You could, since the diagonals bisect each other, you could use those lengths to find
Okay?
side
Good.
lengths of the triangle.
Let's go for that first. Okay.
Say BC, A, BA.
Because
Was that one of our theorems?
The parallel right sides.
They're parallel.
Two pairs. Oh.
Are you sure about that though?
No.
It's a good idea though. I like it. So what's the first step we should put though? You guys just gave me all the ideas.
Oh,
for the first step.
A, B, C, D is parallelogram.
Okay, I should put what I was given, right? It is a parallelogram, and I should put why
Given.
I was given. Okay. Now you guys both gave me some good stuff. Let's put Jake's first. What did you say again, Jake?
I said BC equals AD and BA equals.
So BA is the same as CD. He said this, but those are the same. Did one of our three things say that? We had opposite angles were the same, angles that are consecutive add up to 180, and diagonal stuff. Did we have that? We didn't, but that's one as well. I think this is one you could just think of yourself. If you've got a parallelogram, besides these being parallel, they're also the same size, aren't they? So that's like a fourth thing that you know. These sides have to be the same, and these sides have to be the same. Now, why did I pick that one and not the other one?
Because
What am I aiming for? What am I trying to do?
That says that.
I'm shooting for the triangles, aren't I?
Yeah,
Do I need this for the triangles?
Doesn't have anything to do with the two others.
That's right. So this is because opposite sides of a parallelogram are parallel, but they're also
Congruent.
congruent. Okay? That should make sense. If you look at a parallelogram, they're the same size.
So BC.
Yeah, that's true. But do we need that, Chelsea? Think about what your goal is. I put it in blue, right? Does the blue have anything to do with those?
No.
Right? So that is true, but I don't need it. You could write it down, I mean it'd be fine, but it wasn't really needed.
I have the next B. Yeah, B equals A, and then A, yeah.
Okay, are you guys hearing them? They're using that other one we learned with the diagonals. They're saying this diagonal's cut in half, so I know these two pieces are the same. This diagonal's also cut in half, so I know those two pieces are the same.
You got it.
And now I've got it. You tell me why in a second.
SS.
Okay, so BE is congruent to what? Someone else who didn't tell me. Sean, BE is congruent to?
B is congruent to B.
Okay, and Casey, CE is congruent to what?
Or,
Okay,
I said,
and why is that?
Because
Yeah, essentially, so we can write that by saying diagonals
Bisecting.
of a parallelogram bisect. You know, something like that, that's good. The diagonals bisect, you could say that, that'd be good.
That's awesome looking parallelogram.
You are correct.
Mine are looking like that too.
I'm trying to go fast, right? It's That's our theme for a couple weeks. Okay. Now, Logan, you said that was good, so what should I put here then? We're done the last
Yeah,
step.
triangle AEB is the same as triangle CBD.
Why?
Because would it be SSS?
We clear with why he said side, side, side? Because now we've got side, side, side for the triangles. What are the other four? So these are gonna come back in chapter 7.
SAS, HS,
H,
HL, HL.
leg,
Angle side.
there's the 5. So those will come back in chapter 7, they're exactly the same, but pretty much the same. Alrighty, I think that's good.
Kicked on the open side. We had him.
Come on, babe.
Kicked on the open side, kicked on
Hey guys, this one is not due until Thursday, but tomorrow we're gonna do another section. So there are 2 sections due on Thursday, so I'd get this done tonight if I was you. It's tonight right now, you guys have a lot of time right now, so you should be able to get a lot of it done.